So we're continuing off of this problem where we tried to find the possible roots using the rational roots theorem. And so the last video I went over how to apply this theorem to get all possible rational roots. And I mentioned that these are just possible roots and we want to figure out what are the true roots. Oftentimes in problems they will just say give us all the possible roots, and other times they'll say give me one root of this equation. Great. So now what we're going to do is we're going to just choose any random possible root. Oftentimes, as a pro tip, most people choose 1 or -1, some easy small number, so that it's easy to plug in, because the idea is we're going to just choose a number and then plug it into the original equation, and we want to make our life easier, so what we should do is just choose a small number. So I will choose 1, and I would recommend anyone choose 1 always. Start with 1. Start with x equals 1. So now we chose 1, and we're going to plug that in for x. And I'll get into this note a little bit later, so let's move this down. Great. So now let's put f of x. This is going to be at f of 1 now. It's not going to be f of x. F of 1, and now we're going to put in 1. So let's actually write down the full f of x problem. Let's actually bring it down here so we can make our life easier. So here's the problem. So now we just want to plug in 1. So we're plugging in 1 here, 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 and here. So now you can just do 1 to the 4th minus 1 to the 3rd minus 3. Always put parentheses whenever you plug in an x, by the way. It's going to make things much cleaner. You put 1 in there, and then you do plus 2. Great. So now we're just going to solve. So if you do 1 to the 4th power, multiply 1 by itself 4 times, you're just going to get 1. Minus 1 minus 3 times 1, so that's also going to be 3. 3 times 1 is 1. Plus 1 plus 2. What do you get here? You get 0 minus 3. This is plus 3. And the answer looks like 0. So this is what it's telling us. It's telling us f of 1 is equal to 0. Okay, so how do I interpret that? Here's the note. If you get 0, you found the root. Hooray, we found the root. But if you did not get 0, then you have to keep trying different roots, possible roots, until you get a 0. So we found the root. Easy. So now, and you can get full credit for this, if generally, depending on your teacher, you would get x is equal to 1 as a true root. This is one of the roots. And so the way you would write this out as a root oftentimes is you would say a true root would be x minus 1. That is the true root. The reason why we're writing it in this format is because what we're trying to say with a root, it means that if I were to divide this equation by a certain number, then I'm not going to get a remainder. And so what I mean by that, right, is that with f of x, you can factor it, right? So oftentimes we'll see, like, I'm going to just make something up. It'll be x minus 1. And so this is very simple, right? And so the roots in this case would be x equals 2 and x equals 1. These are roots from this. And so same idea, right? When I'm showing you here, when I wrote it in 2 different ways, I'm just showing you, I guess, if it was in a factored form, it would look like x minus 1, and then the true root you could say is x equals 1. So that is how you would do it for this. And then let's just do a different number just to kind of prove the point. So let's put in 2 to show what it would look like. So if I did 2 instead, so you just delete all this and then put 2 here. Let's put 2. So 2 to the 4th power, that is much harder than 1 to the 4th power. So you can just think about it like this, right? This is going to be 4. This is going to be 4. 4 times 4 is 16. You can imagine if a root is 8 or 7, it might be more difficult to think of. 2 to the 3rd is going to be 8 minus 3 times 2 to the 4, 2 to the 2. 2 to the 2 is 4. Plus 2 plus 2. So now what do we get here? We get 8. We get minus 12 plus 4. So what do we get here? We get minus 4 plus 4 equals 0. Wow! I guess we have multiple roots. We have multiple possible roots, which is totally possible. So we found another possible root, another true root out of these possible roots. Another possible root we found was f of 2 is equal to 0. Therefore, x minus 2, or you could say x equals 2 is a root. Great. Now let's see if we can find a non-root. Okay, let's do x minus 1. Okay, x minus 1. Usually, if you find one root, you're done, and the teacher's just looking for you to find one true root at least. So if you have a negative number and you have a positive exponent, you can assume that the end is going to be positive. Here, negative 1. Negative 1 times negative 1 is actually positive, so it's just going to be 1. Okay. Same idea here, it's going to be 1, so if you do 1 times 1, it's going to be. So depending if it's odd or even, you can tell if the end is going to be positive or negative. So this is going to be 1 minus, this is an odd, so it's going to remain negative 1. And then times 3, and this is going to be even, plus negative 1, plus 2. I like to do that. Okay, great. So here we have negatives and a negative and a negative. It's kind of like a negative times a negative. So that's going to end up being positive. So this is going to be a positive 1 minus 3 plus, this is going to be 1. So that's 2 minus 3 plus 1. This is going to also be 0. It looks like that one is also a possible root. These might all be possible. These all might be true roots. Who knows? So what you can do, just to double check, we can also do negative 2, just to see if they're all possible roots. Okay. Let's do minus 2. So we talked about it last time. 2 to the 4th is 16, so it's going to be 16 here. But the minus, what happens to the minus? The minus goes away because it's an even. So here, minus stays. Minus goes away here. Plus negative 2 plus 2 here. This is going to be 0 plus 12 minus. These kind of cancel each other out, these negatives, so it's going to be 8 plus 16. And the plus is because of that. And what do we get here? We get 24 minus 12 is equal to 12. That doesn't look like 0. That is not 0. This does not equal 0. So that means f of negative 2 is equal to 12, which is not equal to 0. Which tells you x equals minus 2, or x plus 2. Yeah. This is not a root. We know it was a possible root. It is a possible root. But we found through doing this calculation that it is actually not a root. So what did we get here? We got 2 was a root, 1 was a root, negative 1 was a root, negative 2 is not a root. And so any of these you can't go wrong by listing as roots except -2. But if the teacher said, what are all possible roots? Then you would list all of these, including -2. Let me know if you have questions.